Top 20 Aircraft Engineer Interview Answers and Questions. Dreaming of a career that keeps aircraft flying safely and efficiently? Whether you're gearing up for your first interview or aiming for a top-tier engineering position, mastering the right answers can set you apart. In this guide, we break down the top 20 aircraft engineer interview questions and answers with expert-level insights, real-world examples, and practical tips to help you land the job and soar in your aviation career. Let's lift off and get you interview ready, one question at a time. 1. Can you describe your experience with aircraft maintenance and repair? Throughout my career, I've gained hands-on experience in both scheduled and unscheduled aircraft maintenance. This includes performing line maintenance, routine checks, A, B, C checks, and resolving discrepancies found during inspections. I've worked on hydraulic, pneumatic, electrical, and fuel systems, ensuring all repairs meet airworthiness standards. My role often involves troubleshooting faults, replacing defective components, and performing system tests to ensure reliability and safety. I've also been responsible for maintaining detailed maintenance logs and coordinating with technical teams and OEMs to resolve complex issues. My experience has taught me to work efficiently under pressure, especially during aircraft turnaround times. I consistently follow the Aircraft Maintenance Manual, AMM, Illustrated Parts Catalog, IPC, and all relevant regulations. My goal is to keep aircraft airworthy while minimizing downtime, ensuring safety and efficiency are never compromised. 2. What types of aircraft have you worked on previously? I have worked on a range of commercial and regional aircraft, gaining experience on Boeing 737 and Airbus A320 family jets, as well as Embraer 190s. My responsibilities included performing line maintenance, fault diagnostics, and major overhauls on these aircraft types. I've also been involved in component replacement, software updates, and system checks specific to each aircraft's design and operational requirements. Working across different models has helped me understand their unique mechanical and electronic systems, maintenance planning, and OEM compliance procedures. For example, the Airbus A320's fly-by-wire system required specialized troubleshooting approaches, while the Boeing 737's older systems emphasized more manual inspections. My broad experience allows me to adapt quickly when transitioning to new aircraft types, and I consistently refer to each model's specific AMM and fault isolation manuals, FIMS. This adaptability and aircraft diversity exposure strengthen my ability to work across various fleet types safely and effectively. 3. How do you ensure compliance with aviation safety regulations? Compliance begins with strict adherence to aviation regulatory standards such as EASA, FAA, or local CAA guidelines, depending on the region of operation. I always follow the maintenance procedures outlined in OEM manuals and check that all service bulletins, SBS, airworthiness directives, ADS, and engineering orders, EOS, are up to date. Before performing any task, I review the latest documentation and ensure required tools and parts meet calibration and certification standards. I also conduct detailed inspections, use proper torque settings, and verify critical steps with a second technician if required. Accurate record keeping is essential. I ensure all work is logged in the maintenance management system and signed off by appropriately licensed personnel. Regular training and audits help me stay informed of any changes in safety regulations. Ultimately, compliance is about fostering a safety-first mindset across the team, encouraging accountability, and never cutting corners regardless of time or budget pressures. 4. What steps do you follow when conducting a routine aircraft inspection? When performing a routine aircraft inspection, I begin by reviewing the maintenance schedule and checking for any open defects or deferred items. I gather the necessary tools, manuals, and safety equipment, and verify the aircraft's documentation to confirm airworthiness status. The inspection process follows a systematic approach, starting with an exterior walk-around to check for structural damage, fluid leaks, or missing fasteners. I then move to internal systems, examining avionics, hydraulics, landing gear, control surfaces, and engine compartments based on the inspection type, e.g., A-check or C-check. I carefully document findings, perform corrective actions if needed, and conduct operational checks to confirm system functionality. Finally, I update the technical logs, ensuring all entries are accurate and signed off. Safety is prioritized at every stage, and inspections are never rushed, regardless of time constraints. 5. How do you handle unexpected technical issues during a pre-flight check? When an unexpected issue arises during a pre-flight check, I remain calm and follow a structured troubleshooting process. First, I assess the reported fault by reviewing flight crew reports and checking the aircraft's Electronic Centralized Aircraft Monitor, ECAM, or Central Maintenance Computer, CMC, for fault codes. I consult the Aircraft Fault Isolation Manual, FIM, or Troubleshooting Manual to identify potential causes. After isolating the issue, I perform visual and operational checks, using calibrated tools or test equipment if necessary. If parts need replacement, I ensure correct part numbers and certifications before installation. All actions are documented in the aircraft's technical log, and I consult with senior engineers or maintenance control if the issue is complex or time-sensitive. Communication with the flight crew is key, keeping them updated while ensuring no compromises on airworthiness. If the issue can't be resolved in time, I recommend grounding the aircraft until fully rectified. 6. What is your experience with avionics systems and troubleshooting them? I've worked extensively with avionics systems, including flight management systems, FMS, autopilot, communication and navigation equipment, and electronic flight instrument systems, EFIS. Troubleshooting starts with reviewing fault codes through the aircraft's central maintenance system or diagnostic displays. I cross-reference findings with the Avionics Fault Isolation Manual, AFIM, and perform signal checks, continuity tests, or component swaps if necessary. I've resolved issues such as unreliable altitude readings, navigation discrepancies, and faulty transponder responses. My familiarity with modern glass cockpits, like those in the Airbus A320 and Boeing 737NG, has helped me handle digital system complexities effectively. I always verify software configurations and ensure firmware updates are correctly applied. Safety and documentation are crucial, so every action is logged precisely, and repaired systems are tested thoroughly before return to service. I stay current with training on evolving avionics technologies, including satellite communications and integrated modular avionics, IMA, to maintain my troubleshooting proficiency. 7. How do you document maintenance and repair work? Accurate and detailed documentation is vital in aviation maintenance. After completing any maintenance task or repair, I record the job in the aircraft's maintenance logbook and/or the airline's computerized maintenance tracking system, e.g., AMOS, TRAX, or CAMP. Entries include the date, time, aircraft registration, task card reference, description of the work performed, part numbers, serial numbers, and technician license numbers. I also record torque settings, test results, and any replaced components, ensuring traceability. If applicable, I attach copies of service bulletins, SBS, or airworthiness directives, ADS, complied with during the task. Once completed, I review the entries with a licensed engineer or inspector who signs off on the job. This ensures regulatory compliance and airworthiness. My approach is to always maintain transparency and accountability through clear, consistent records, which supports audits, improves reliability analysis, and contributes to the overall safety culture within the maintenance organization. 8. Describe a time when you found a critical fault in an aircraft. What did you do? During a routine A-check on an Airbus A320, I discovered a hydraulic leak near the landing gear actuator. The leak was minor but located dangerously close to electrical wiring. I immediately reported the issue to the certifying engineer and isolated the aircraft to prevent further pressure buildup in the system. After referencing the Aircraft Maintenance Manual, AMM, I disassembled the affected section and found a cracked hydraulic fitting. I replaced the part with a certified component, cleaned the area thoroughly, and conducted a full hydraulic system pressure test. Once the system was verified as leak-free, I documented the repair and had it signed off by a licensed engineer. I also submitted a maintenance report to Fleet Engineering for tracking recurring issues. This incident reinforced the importance of thorough inspections, even during routine checks, and demonstrated my ability to act quickly and responsibly when identifying safety-critical defects. 9. What are the most important checks during an A-check and C-check? An A-check is a relatively light, scheduled maintenance inspection performed approximately every 400 to 600 flight hours. Key tasks include checking fluid levels, inspecting emergency equipment, verifying avionics functionality, testing lighting systems, and visual inspections of the fuselage, wings, and engines. Minor lubrication and filter changes may also be conducted. A C-check is more comprehensive and occurs every 18 to 24 months or a specific number of flight hours. It includes all A-check tasks plus in-depth inspections of aircraft structures, landing gear, cargo compartments, flight control systems, and major mechanical and electrical systems. Components are removed for inspection, non-destructive testing, NDT, may be used, and software or firmware updates are often applied. Cabin interior, safety systems, and corrosion control are also reviewed. In both checks, adherence to task cards and manufacturer instructions is critical, as is proper documentation. Safety, compliance, and minimizing downtime are my top priorities during all inspection phases. 10. How do you stay updated with changes in aviation regulations and technologies? Staying current is essential in aviation due to constantly evolving regulations and technologies. I regularly attend in-house training programs and recurrent courses offered by my employer or certified training organizations. I also maintain subscriptions to industry publications such as Aviation Week, Flight Global, and updates from regulatory bodies like EASA, FAA, and ICAO. I review manufacturer service bulletins, SBS, airworthiness directives, ADS, and engineering notices as part of my daily maintenance briefings. Online forums and communities like the Aircraft Maintenance Technicians Association, AMTA, and LinkedIn aviation groups also provide valuable insights from other professionals. Additionally, I take e-learning modules provided by aircraft manufacturers, e.g., Airbus World, Boeing Toolbox, to stay familiar with updated maintenance procedures and technological advancements like composite repairs, electric taxiing systems, and avionics integration. Continuous learning ensures I maintain high standards in my work and can confidently implement new practices in a safe, compliant, and efficient manner. 11. What software tools or diagnostic equipment are you proficient in? I am proficient in several aircraft maintenance and diagnostic software tools, including AMOS, TRAX, and CAMP for maintenance tracking and planning. These systems help manage scheduled maintenance, monitor component life cycles, and ensure compliance with regulations. For aircraft diagnostics, I've used Boeing's Airplane Health Management, AHM, Airbus's AIRMAN, and onboard central maintenance computers, CMC, to read fault codes and isolate issues. I'm also comfortable using OEM-provided tools like Boeing Toolbox and Airbus World for technical documentation and service bulletins. In terms of physical diagnostic equipment, I'm experienced with multimeters, borescopes, pitot-static testers, and hydraulic pressure testers. I also use non-destructive testing, NDT tools like ultrasonic and dye-penetrant kits during structural inspections. Proper calibration and certification of all tools are crucial, and I always verify tool status before use. My comfort with both digital platforms and hands-on equipment ensures accurate diagnostics and efficient troubleshooting in a wide variety of maintenance scenarios. 12. Can you explain the process of engine removal and installation? Engine removal and installation is a precise, safety-critical process. First, I review the Aircraft Maintenance Manual, AMM, for the specific procedure and ensure all required tools, fixtures, and safety gear are available. I start by disconnecting the fuel lines, electrical connectors, control cables, and bleed air ducts. Then I deactivate and lock out relevant systems to prevent accidental operation. Once all components are disconnected, I support the engine with an approved stand or hoist and carefully unbolt it from the pylon or wing structure. Removal is completed with checks to prevent any structural or component damage. Installation is essentially the reverse. The new or overhauled engine is aligned and mounted correctly using torque-specified bolts. All connections are reattached, secured, and double-checked. I then perform leak checks, engine run-ups, and operational tests to ensure all systems are functioning correctly. Detailed documentation and sign-offs follow, verifying the aircraft's airworthiness before return to service. 13. How do you ensure all work is completed according to the manufacturer's specifications? I strictly follow the Aircraft Maintenance Manual, AMM, Component Maintenance Manuals, CMMS, and other OEM-issued documents such as Service Bulletins, SBS, and Airworthiness Directives, ADS, for every task. Before starting a job, I review the relevant task card and cross-reference it with the latest version of the AMM to ensure instructions are current. I verify that all parts used have the correct part number, serial number, and airworthiness certification. Torque values, calibration requirements, and safety margins are meticulously followed using properly certified tools. During complex tasks, I consult with a licensed engineer or quality assurance inspector to double-check critical steps. Work is documented thoroughly, and inspections are conducted at each stage as needed. Additionally, I attend recurrent training and technical briefings to stay updated on procedural changes. Ensuring compliance with OEM standards is fundamental not only to safety, but also to maintaining the reliability and longevity of the aircraft. 14. What do you do if you disagree with another engineer's assessment? Disagreements in technical assessments can occur, and it's important to approach them professionally and objectively. If I disagree with another engineer's evaluation, I first seek to understand their reasoning by discussing the issue in detail and reviewing the documentation or fault data together. I consult the Aircraft Maintenance Manual, AMM, Fault Isolation Manual, FIM, and any relevant service bulletins or airworthiness directives to find a definitive resolution. If the disagreement persists, I escalate the matter to a licensed certifying engineer or shift supervisor for a final decision. Safety is the top priority, so I never proceed with work unless I am confident the correct and compliant course of action is being taken. I document the issue accurately, noting any actions taken or advice received. Open communication and mutual respect are key to resolving such situations constructively and ensuring the continued airworthiness of the aircraft. 15. Describe your experience with aircraft structural repairs. I have hands-on experience with a wide range of structural repairs, from minor sheet metal patching to more complex structural component replacements. I've worked on aircraft fuselage panels, access doors, wing fairings, and undercarriage support areas using OEM-approved methods. My work often involves damage assessment, non-destructive testing, NDT, removal of damaged materials, and repair or replacement using rivets, fasteners, or bonded panels. I refer to the Structural Repair Manual, SRM, for repair limits and instructions, ensuring compliance with manufacturer specifications. For composite repairs, I follow exact curing and bonding procedures, including vacuum bagging and temperature monitoring where required. Precision and cleanliness are crucial, especially when dealing with pressurized structures. After repairs, I conduct leak checks, visual inspections, and dimensional verification to ensure structural integrity. I always coordinate with quality assurance and licensed engineers for inspections and sign-offs. My methodical approach ensures durable, compliant repairs that restore full airworthiness. 16. What is your approach to managing time under tight maintenance schedules? Working under tight schedules is common in aviation, especially during turnaround or AOG situations. My approach starts with prioritizing tasks based on safety, regulatory compliance, and operational impact. I begin by thoroughly reviewing the job cards and planning the sequence of tasks with the team. Clear communication with colleagues, certifying staff, and support departments ensures everyone is aligned. I group similar tasks to avoid duplication of effort and use downtime efficiently by preparing tools, documentation, and components in advance. I rely heavily on time management techniques such as time boxing and continuous monitoring of progress to stay on track. If delays occur, I promptly escalate the issue or seek alternative resources. Even under pressure, I never compromise on safety or quality. My experience has taught me how to balance speed and precision while maintaining full compliance with aviation standards, which is critical in maintaining airworthiness without delays. 17. How do you prioritize maintenance tasks during a turnaround? During a turnaround, time is limited, so task prioritization is key. I begin by addressing safety-critical and flight-essential systems first, such as brakes, engines, flight controls, and avionics. I consult the aircraft's technical log and review any defects reported by the flight crew. Deferred defects with MEL, minimum equipment list, provisions are considered next, ensuring they are within allowable limits. I assign tasks based on urgency, resource availability, and the complexity of each issue. Team coordination is essential, so I communicate with other engineers and ground handlers to avoid bottlenecks and overlapping work. Simpler checks like oil levels, light tests, or tire pressure are completed while awaiting parts or documentation for larger tasks. I always factor in sign-off requirements to ensure each job is completed and recorded before departure. This systematic, safety-first approach ensures on-time departure without compromising compliance or aircraft reliability. 18. Tell us about a challenging engineering problem you solved. During a heavy check on a Boeing 737, the crew reported intermittent autopilot disengagements. Initial inspections and fault codes pointed to the yaw damper system, but multiple components tested within limits. I reviewed previous maintenance records and discovered similar complaints dating back months. Suspecting a deeper issue, I conducted a full wiring continuity test and found a chafed wire bundle near the rudder pressure transducer, an area rarely inspected. The damaged wires were causing signal interference. I repaired the wiring per the Standard Wiring Practices Manual, SWPM, rerouted the harness for better clearance, and conducted a successful system test and flight verification. This issue required persistence, teamwork, and a methodical approach to isolate. It reminded me that not all problems are straightforward and reinforced the importance of root cause analysis over quick fixes. The fix not only solved the problem but also prevented future occurrences, improving fleet reliability. 19. How do you ensure all parts and materials meet airworthiness standards? Before using any part or material, I verify its airworthiness certification, checking the Certificate of Conformance, COC, EASA Form 1, or FAA 8130-3 tag, depending on the regulatory authority. I also inspect for correct part numbers, serial numbers, and batch details to match the aircraft's Illustrated Parts Catalog, IPC. All parts must come from approved vendors or stores, and I never use components that are undocumented, expired, or appear damaged. For critical systems like engines or flight controls, I double-check traceability documents and shelf life records, especially for consumables like O-rings, sealants, and lubricants. I cross-reference part applicability using the aircraft effectivity list. After installation, I document the part's usage in the aircraft logbook and maintenance system, ensuring compliance. Regular audits, internal training, and a clear understanding of regulations help me maintain high standards. This meticulous approach ensures both legal compliance and the operational safety of the aircraft. 20. Why did you choose to become an aircraft engineer, and what motivates you in this role? I chose to become an aircraft engineer because of my passion for aviation and fascination with how complex machines operate and fly. From a young age, I was captivated by aircraft, and this curiosity evolved into a desire to work behind the scenes, ensuring their safety and performance. What motivates me daily is the responsibility of maintaining the highest safety standards and the satisfaction of solving technical problems under pressure. I find it rewarding to know that my work directly impacts passenger safety and airline efficiency. Every aircraft that leaves the ground safely after a maintenance task gives me a sense of accomplishment. I also enjoy the continuous learning aspect, keeping up with new technologies, aircraft systems, and evolving regulations. This role combines hands-on technical work with critical thinking and teamwork, making it both challenging and fulfilling. Being part of the aviation safety chain is what drives me to excel. Master these aircraft engineer interview questions to boost your confidence, impress hiring managers, and secure your dream role in aviation. Stay sharp, stay safe. Good luck on your journey.